What is hashing? See, when if you are having a problem, let's understand this hashing with a problem first. Okay, you are supposed to write a program to print the first repeated character in a given string. Okay, if there are duplicate elements in it. Suppose if I give something as, maybe if I give a string A, B, 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 C, C, this is the string which I have given. Given this string as an input, my problem here is to print the first repeated character. There are so many characters here. Which character is repeated first? A is repeated first. In this case, A will be the answer. Suppose if I have the string as A, B, C, 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 D, D, again E. If this is my string, the first repeated character, meaning having duplicate elements, is C. Okay, right? Or other case, this problem can also be taken like this: A, C, B, D, E, A, C, and so on, like this. Which one is the first repeated character here? A is repeated, you see, A is repeated here, right? So, A is the repeated character in this case. How do you solve this problem? Okay, so one way is to know, if we take this base case as an example, what we can do here, you will iterate over the elements. You will iterate, you will see, you will take this first element, that is A of 0, or in this case it is str of 0, and you will take this and you will compare with if the indexing is 0, you will start comparing from 1 to n minus 1. You will check if A is available here. Is A is matching with this? Yes, it is matching. You will stop there and say A is the first repeated character. So, you have to write for loop, two for loops you have to write, where you will be iterating, taking this as a fixed position, changing I is fixed to 0, j will be changing from 1 to n minus 1. You will be checking. This is again a straightforward case. Let us take the same example: A, B, C, D, A, E, B, A, something like this I have. Now, when you take A, you will check with A and is this same? No. Is this same? No. Is this A and D same? No. A and D are same? Yes. So, your I is fixed, your j is changing. Suppose there was no A also here. Suppose there was no A also. It was something like this. Then first loop, first iteration, I equal to 0, j from 1 to n minus 1 will fail, meaning I did not find a repeated character. A did not encounter again. So, I will increase my I to 1 now, second time, upper for loop. Then again I will begin from 2 to n minus 1. I will begin from 2 to n minus 1. So, I will check B with C, B with D, B with E, B with B. Yes, I found it. I will say B is the repeating character, right. So, if you see the logic here, we are writing for I equal to 0, I is less than n minus 1, I plus plus, for some j equal to I plus 1, j is less than n minus 1, j plus plus. Okay. You are checking there if s of 0 or s of I, okay, if it is equal to s of j. If it is matching, wherever it is matching, you are printing that, you are printing, no, you are simply say C out of s of I, that is a repeated character, and break. Maybe they are asking to print the repeated character or say whether there is a repeated character or not, depending on the problem, right. So, this is one problem. If you see what is the time complexity of this, since I am using 2 for loops, since we are using 2 for loops to solve this problem, right, the time complexity will be order of n square. Okay. Now, can we have a better solution for this? Can we have an alternate solution for this, where I can reduce the, what we say, time complexity from order of n square to little less, maybe order of n log n or order of n, something like this. Can we reduce this? Okay. Can you please tell me, can we reduce this approach? How can we do this? Please try. Instead of using 2 for loops to print the first repeated character, what can we do here? So, one solution could be, you can create a temporary array int a of 26, right, where why 26? Because there are 26 alphabets. Okay. Generally in English we have 26 characters, so we are taking 26, assigning everything with 0, the array looks like this. So this is my array. Indirectly it means this location is pointing to character A, this is designed to character B, this is for C, this is for D, and so on, this is for Z. Now you iterate with only one for loop, you can do that. You iterate over these elements. Okay, for I equal to 0, I less than strlen of that string I plus plus. You iterate over this length of the string, over the length of the string I plus plus. Now, okay, this array A array of this str of I. Okay, first time I is 0, I is 0, I 0 means str of 0 means A, that location A. How can I get 0? We know the mapping that A, alphabet A, its position is this box, this first box. Alphabet B, its position is this first box, second box. How will I get that? If you can subtract this by single A like this, just do this statement. Okay, A of str of I, that is str of 0, 0 means A, this A character A minus character A, ASCII value difference it will do, that is 0. So this box, that means A of 0. What is A of 0? This box. You do it plus plus, means this will become 1 now. This will become 1. Okay, again go up from here again go up. I plus plus, I becomes 1. 1 means it comes to C. So str of I means C. C minus A. ASCII difference of C minus A will give me 2. So A of 2. A of 2 means this box. You increment it, it becomes 1. Like this, you see your for loop, your no, it is a single for loop now. It is a single for loop. With the single for loop, I am able to fill the content into this array. I am able to fill the counts of values into this array, temporary array A. Okay. So with this, I reduced it to order of n. So this using this temporary array here means using hashing concept or hash table. Okay, don't see hashing as a new data structure or a new thing. It's just same like your array. Okay, obviously it is an array only, but we treat it as a hash table. We call it as a hash table. Okay, meaning we are using a temporary array which makes our problem solving easy, which makes our processing easy. Right. So this is very popular logic. Mostly in string problems you will be seeing this kind of thing. To find out that location, to find out the repeated character, you have to take that character minus A means it will give that index. That index you can update. So there are so many problems on this line. Tell which is the most repeated character. There is a question given a string which is the most repeated character. So you will repeat this logic. You will have counts in the boxes. Okay, you will have the counts in the this array. A array will contain some counts, 2, some 3, 1, 0, something counts. Go there, find out the one which is having more count. Find out the one which is having more count. With this count, this index has more count. It means you just take A plus that index you add. Character A plus this index you print it, you will get the most repeated character. Okay. So this logic is very much used in lot of problem solving, right. So single for loop, I am able to do this, A of str of I minus A, right. So I am using a temporary table, I am using a temporary array. Hashing means for solving a problem without knowing the concept of hashing, you have solved lot of problems already, right. So taking help of a temporary memory location or a temporary array, which we call here as a hash table, right, is the that is the concept of hashing. For this problem it is okay, right, since it is character, since the question was given a set of characters, find out the most repeated character, find out the first repeated character, like this we have solved some problems, right, we can do that. But what if the integer array is given? What if a integer array int A of some 10 is equal to I have given 10, 15, 12, 13, again 15, 12, right, some 17, 1, 2, 3, 4, 5, 2, 7, 9. like this 10 elements are given. Now I have to find out the most repeated element or the first repeated element. For this, how will you do? We cannot take a temporary array of size 20, no, I cannot take temporary array of size 20 like this. I cannot use that logic which I used for character array or that string. Okay, I cannot take something like this and hold count. So at 9 the count will be 1, at 15 the count will be somewhere here, the count will be 2, again for 12 it will be 2. Like this we cannot have for array. Why we cannot have for numbers? Because there is no limit for this range. The array A of 10 contains, it can contain any number of 10 integers. Do we have any limit for integers? No, even 1000 is one integer, or 10k is also one integer. So I cannot hold them, I cannot create it. How long should I create this temporary array? We don't know. So for character array, it is possible to use a temporary array of size b of 26, because we know the character set is limited. But for when you say integers, you have unlimited data with you, you don't have any limit. So you cannot use the logic of a temporary array. Okay, therefore here if you have an array like this, if you want to solve some problems of this kind, you have to use the concept of hashing. Okay, array and hashing are not same. It is same in the case of strings, but for integer array, hashing and arrays are different. Okay, they are not same. Why we cannot use arrays? Because if I want storing this 50 at here, if I am storing 50 here, 201 here, right, 6 here, 33 here, if I am storing values like this, right, this is not sufficient because there are so many values. Where will you store those values, right? So we have to have some mapping. We should have, if the integer array is given to us, int a of 5 is equal to some 7, 3, 2, 9 and 1. You should have some mapping. We should have some mapping between this array and another array. I should have some mapping between that array and another temporary array. That mapping, the process of mapping keys to locations is called hashing. Okay, you will understand this much better when we see the other concepts, or the process of how do we use the hash table, right? So the problem here is, if you are given a string with and you are asked to find out the first repeated character using a temporary array, you can do that. But if I give an array, integer array elements, if I give some elements like this, then we cannot have such kind of a temporary array, because the size is very big. Because 1000 can be one number here, 33 could be another number, 972 could be another number. Like this I can have n number of elements in the array. So I cannot create a very big array here, temporary array. So for these kind of problems, okay, if you want to do it easier and faster way, we use hashing, right? So let's go and study different concepts in hashing. So hashing is a technique used for storing and retrieving information as quickly as possible. Okay, it is used to perform optimal searches and is useful in implementing symbol tables in compiler design. Okay, symbol tables in compiler design, which you will be studying in future. Okay, right. So trees chapter we saw that the balanced binary search tree support operations such as insert, delete and search in order of login time. In applications, if we need this operations order of 1, then hashing provides a way. Hashing is the best way. That's what I said. You can improve the performance and reduce the time complexity. Okay. However, the worst case is still order of n only, but the average case is order of 1 using hashing, right? So we understood this with an example. Now let's see what are the key components of hashing. Hashing has 4 main components. First one is hash table, hash functions, collisions and collision resolution techniques. Let's try to understand each of them one by one. What is a hash table? That temporary array which I am using to store the values is my hash table. In the example of this, in this example, given a string A, B, C, D, E. Okay, I am using a temporary array, right? I am creating a temporary array of size 26 and I am filling all with zeros. In that I am trying to fill the count of these characters in this array. So, this temporary array where this, what are the actual keys? Keys are these. Okay, in hashing language, elements of an array are called as keys. Okay, this key A, B, C, D, these keys, the locations of these keys or some property of these keys I am storing in this array, right. So, hash table is that where we use, right, we can store the key at some location. That is what, no, here what I am doing, I am creating A of size 26, I am creating A of size 26, then indexing I have, you know that the key value is A, its location in A is 0, this is the index, this index belongs to key A, next key is B, this is the index of that key. Okay. So, in the hash table we store the location, we know we store the location of the each character. See here, right. Let us understand it theoretically, that again I will make it very simple. When you are solving a large problem, you might have to use some temporary arrays sometime to make your processing easy. Those temporary arrays which you are using in your big when you are in solving the big problem, we call it as hash table or hashing. We call that as hashing, right. So, hash table is a generalization of array. It is same as your array. With an array, we store the element whose key is at k at a position k on the array. Okay. In array, you are storing something like this: 10 at this location, 20, 30, 40, 50. Okay. Right. So, this is the indexing here. We are storing using indexing at position k. We are storing at position. So, this is the position, no, first location, second, third, fourth, accordingly. That means, given a key k, we find the element whose key is k by just looking at the kth position of the array. Okay. So, that is what we have used for that string example, right. Suppose this is the array of size 26. Okay. I have an array of size 26, right. This is index 0, 1, 2, 3, 4. You know, right, this is meant for A, you know that this is meant for Z, because I have taken a array of size, I have taken array of size 26. So, we already know, that means given a key k, suppose k is given as C, we find the element whose key is k by just looking in the kth position, by looking at the kth position, meaning third position here, third position, because this is the third character, you are looking at the third position and you are telling what is the element in that location. This is called direct addressing. This is called direct addressing, or other way, direct addressing can be seen like this. I have elements 0, 1, 2, 3, 4, 5. What is the index of this array? 0, 1, 2, 3, 4, 5. If you want to know, see, given a key k, suppose k is given as 3, we find the element whose key is k by just looking at the kth position. Okay, right, that position we are looking. So, maybe I could store something like this, 1, 2, 3, 4. Now, it makes meaningful. So, k is given as 3, look at the third position, you get the value. This way it is called direct addressing. This approach is called direct addressing. If we have less locations and more possible keys, then simple implementation is not enough, right. So, we have some challenges here. We cannot store elements. Suppose the elements, let me give an example. Okay, I am having an array A of size 10 with 25, 12, 22, 33, 43, 56. I have some elements like this. Okay, I am having 6 elements. Let me put another one, 15. Right. When I want to store them in an array, 0, 1, 2, 3, 4, 5, 6. I want to store in such a way that I, if I give this key, if I tell this key, I should get that element in that location. How? Suppose the algorithm here is 12 modulo 10. If I am doing 12 mod 10, take the first element 25 mod 10. Okay, what is the value? 5. Put 25 here. Next 12 mod 10, so put 12 here. 22 mod 10, that is 2. Can I keep 2 here? 22 here? It is already filled. We cannot fill it like this. We cannot fill it here. Okay, I want to take each of these elements, apply some technique there. Take that element and you do modulo 10 and then store them at that index. Store them at that index. But when 22 comes, I cannot store that in this location too, because there is already an element. That is why array cannot be used. That is why array cannot be used. Right. So, for that we have one option is to use hash tables. We can use hash tables instead of arrays. So, hash table or hash map is a data structure that stores the keys and their associated values. Okay, right? And hash table uses a hash function to map the keys. Which element of the array, where should I store it? We saw an example, we are having some elements like this 13, 33, 42, something, right? Which element should be stored in which location? There should be some mapping. If there is some mapping that this element has to store here, this element has to come here, this has to come here, then that mapping can be done using hash function. The table which I am using to store the values is hash table. The function which is helping me to store these values in their correct position is hash function. Okay. So, let us try to understand what is hash function. Again I will repeat this in simple terms. Hash table is nothing but the temporary array which we are using to store the key values. But how I am storing it? I want to store it using direct addressing format. But if you want to implement direct addressing format, it is difficult in arrays. Direct addressing, it is difficult in arrays, right? So, we have to go for hash tables, right? So, hash table or a hash map is a data structure that stores the keys and their associated values, right? Let us understand hash function, right? So, the hash function is used to transform the key into the index, right? I had an array of 7 elements 25, 22, 13, 33, 42, 56 and 15. I want to store them in a table. I want to store them in a hashing table. I have some keys here like this, indexing. Where should this 25 go? Where should this 25 go? That means that hash function is to transform the key into a index. This 25 should be converted to some index. So, hash function helps in that. So, a basic and the frequently used hash function is that key value modulo the table size. The table size, that is the standard formula, we use it frequently, but this is not mandatory. You can design different hash functions. Okay. So, here the key is 25. What is the table size? 1, 2, 3, 4, 5, 6, 7. So, the table size is 7. So, 25 modulo 7, 7 3s 21, remainder is 4. So, 25 will come here. How I am able to find out this? Using a hash function. What is a hash function? H of key is equal to key modulo table size. This is the hashing function that is helping us to find out a location, accurate location for these keys. Okay, right? Given a collection of elements, a hash function that maps each item into unique slot is referred to as perfect hash function. If, okay, let us take this case, same example, a of 7 is equal to 26, 25, 22, 13, 33 and 16. Okay, I have this array with me here of size 7. 0, 1, 2, 3, 4, 5, 6. Okay. So what is the hash function value? Take the key modulo table size 26, 26 mod 7. So again 7 3 is 21, therefore the remainder will be 5 here. Okay. So I will be putting this in location 5, that is 26. Then 25 mod 7, the remainder is 4, so 25 comes here. 22 mod 7, 7 3 is 21, the remainder is 1, so 22 comes here. Then 13, 13 means it will goes to 6, 13 mod 7 means it will go to 6, 13 comes here. Again 33, okay, what is 33 mod 7 value? 33 mod 7, so 7 4 is 28, remainder is 5. You have to place this 33 at location 5. Do we have empty space here at 5? No, it is already occupied. It is already occupied. So it is some collision is happening. This is called collision. Collision means already there exists an element. You are trying to place another element in that location where there is an element exists already. You are trying to occupy that place. So some collision happens there, right? So what is a perfect hash function? Any hash function that maps each item into a unique slot. But for 26 and 33, it is giving same slot 5. So this is not a perfect hash function. Okay, we will see how to identify, how to prepare different hash functions, right? So, but overall hash function is a function which helps me in converting that key to a index. It helps me in finding out the index, right? So our goal is to create a hash function that minimizes the number of collisions. Okay, the collision should not happen there, right? Is to easy to compute and evenly distribute the elements in the hash table. So your function, designing this function is very important. This plays the game so that there are less number of collisions, right? So one example, one method is folding method. Where do you store this? What is this folding method? Let us understand. See, yeah, here I will take an example here. You are having, you want to store some numbers like this 1 2 3 4 5 5 4 2 3 1 2 3 1 4 5. There are some numbers, some integer numbers. I want to store them in a hash table. Okay, I want to store them in a hash table. When I want to store them in a hash table, we saw that some collision is happening. Why? For this 1 2 3 4 5, suppose the array size is 6. So this modulo 6 if you do, maybe you may get 2 as the location for this 1 2 3 4 5. Even for this 2 3 1 4 5, still you may get the same location. So it is a problem, right? Collision is happening. This location is fixed for one element already. For third element also again this location is coming as the output. Hash function is giving me this location to store the value, but it is already occupied. So how do we do that? How do we store the elements there, right? So for that, what we can do here to store those elements, one method is folding method. What does folding method says? You take the first number 1 2 3 4 5, add every two digits 1 2 plus 3 4 plus 5. You make this sum. What is this sum? 12 plus 34 is 46 plus 5 51. This is 51. Then you do 51 modulo 6. Then you do 51 modulo 6. So this gives me 3. If I put the indexes, this gives me 3. So I can put the value here 1 2 3 4 5. Okay, maybe I take the same numbers here, but if you take something else, right? What was that? Sorry, 2 3 4 1 5. This was the number. Assume. So you take 23 now plus 41 plus 5. You do summation of this. So 23 plus this one 460 69. Now you do 69 modulo 6. It is 3 again. This case it is getting 3, but I think I wrote previously here 3 4 2 1 5, something like this. No, we had 45 here. 3 2 1 4 5. So it is 32 plus 14 plus 5. So this will give me again 46 plus 1 51. Maybe this is, since I am taking same digits, we are getting same answer, but generally it will give different, it is assumed to give different locations. Okay, for these small numbers it will not work, but for large numbers it will reduce the collision chances, right. So what is folding method? If you want to store the phone numbers, if you want to store the phone numbers like this, then you take digits and divide them into groups like this: 4 3, first 2 digits, then 6 5, then 5 5, then 4 6, then 0 1. Do summation of that, you get 210. That 210 you apply the no key modulo 11. Suppose there are 11 slots in the table, you do 210 modulo 11, you get answer as 1. So you can store this in location 1. Like this you can keep doing it. This, there is a high chance this reduces the collisions, but we cannot guarantee 100% collision free. Okay. So this is one important method, folding method. What we try to do, whichever key you want to store in the hash table, you will take summation of two numbers like this. You will take summation of two numbers, add them, you get 210. That 210 modulo table size you do, you get an index. At this index you place the 210, you place this number, this large phone number there, right. That is one method. And there is another method called reverse folding method. What is reverse folding method? Same, take 43, but the next number is 65, no, you do reverse of it, 56. Then this number as it is 55, then next number reverse again 64, because there is 4 6, I am taking 6 4. Next number as it is, you add 219, 219 modulo 11, you get 10. You see, you are getting different locations with a different approach, right. So this is one way to avoid collision. You can even use folding method. How to choose the best hash function? How do we choose, right? So what are the challenges associated with choosing a best hash function, right? An efficient hash function should be designed so that it distributes the index values across the table uniformly. Okay, your hash function should be very nicely designed such that it gives different. See, if I take example as key modulo 10 as an example, right, this will give different answers for me. For some numbers it will give 0, for some numbers it will give index 1, for some 2, for some 3, and for some 9. These are the possible chances of output from this function. So it is distributing evenly. But if I take key modulo, maybe if I take key modulo, if I take for example, let's take 5, key modulo 5, then maybe it is always producing values between 1 to 3 only keys. That can happen. So it should not be like that. It should uniformly distribute across the table. Next, an efficient collision resolution algorithm should be designed. Okay, when the collision is happening, when you are trying to fill the values in that table, hash table, some collisions are happening. What is collision? Having the same element there, no, that box is already occupied. You are trying to fit a new value in there. It is not accepting because that box is full. So there should be one, you should have some proper mechanism to avoid that collision. Okay, right? And we must choose a hash function which can be calculated quickly. See, when we are saying hash function is key modulo table size, this is very easy to calculate. But if you put something like this, key plus I whole square modulo 10 into 4 by 3, some mathematical logic if you include like this, it is difficult to calculate, right. So your hash function should be simple, it should distribute the objects uniformly across the table, and there should be some collision resolution algorithm. Okay. What are the characteristics of a good hash function? When can we say a hash function is better or a good hash function, right? A good hash function has the following characteristics: minimize collision, yes we know, be easy and quick to compute, distribute the keys evenly, okay, use all the information provided in the key in that input array, have high load factor, have a higher load factor for a given set of keys. Okay, this all we understood already, that it should distribute evenly, it should easily compute, it should reduce the collision, right? What is this load factor? It should have high load factor. What is this load factor? Load factor is nothing but number of elements in the hash table by the hash table size. This should be high. Okay, so if you have a hash table like this of size 10, for example, from 0 to 9 indexing, right? I have filled only 3 elements, 7, 2, something like this. Then the load factor is Number of elements in hash table only 3. 3 by hash table size 10. This is 0.3. It should have high load factor, meaning it should properly fill this table. Number of elements should be nicely occupied into the table, hash table. Okay, more number of elements should be occupied. That is the characteristics of a good hash function. Okay, so this is the formula for load factor. So if we quickly summarize what we have seen till now, right? We have understood a problem where we need to use hashing. Hashing is nothing but using a temporary array as a hash table, so that your processing becomes easy. You reduce the time complexity. Right? It has 4 components: hash table, hash functions are the base. Then we have collision resolution techniques. What is a hash table? That temporary array which I am using is my hash table. Okay, how to fill elements into this? Using hash functions. What is the default hash function? The default hash function is key, take that key, modulo table size. This is the easiest hash function what we have. Using this, you can fill the elements into the table, right?